Okay, Assalamualaikum and good afternoon to all my students. Today we will proceed to chapter 5 known as a volumetric analysis. So the learning outcomes at the end of the chapter, you should be able to, the first one, explain the concept of volumetric analysis, define acid-base titration, endpoint, equivalence points, and can know about the indicator, perform calculation on pH. So actually in CHM 138 you already learned how to calculate the pH of the solution. Perform calculation on acid-base titration, direct titration and back titration. Able to sketch titration curve for acid-base reaction. And the last one is explain the concept of back titration. As an introduction, so titration, there's a few types of titration here. So acid-base titration, oxidation reduction, complex formation, and the precipitation reaction. But for this subject, CHM 256, known as a basic analytical chemistry, so you just learn about acid-base titration. So look up to volumetric analysis. As a whole, it is measurement of the volume of reagent needed to react with analyte. So normally your analyte is placed in conical flask. Volumetric titration add increment of reagent to a solution of an analyte until the reaction is complete. Is judged to be complete where there is a reaction occur, and then you can observe the difference before and after. So the ideal volumetric titration, the reaction must be complete and the reaction is rapid. So this is the titration apparatus setup. So required, you need to have the burette that place your titrant inside of this burette, and you have the analyte inside of conical flask. The concept of volumetric analysis, the reactant will react with a standard solution from burette of a known concentration called titrant. This is I mentioned before. So the solution placed in the burette known as a titrant. The analyte in which the concentration to be determined is placed in a conical flask. The appropriate indicator will add into the conical flask to determine the end point, shown by the color changing of the indicator. That is the end point, which is end point will help the analyst to determine the, the, the changing of the color, and meaning that it reached the complete of the reaction. This is the titration requirement. The first one is there should be an obvious change in solution properties when the reaction has complete. There should be no side reactions. So meaning that in your experiment, last experiment before PKP, bila you buat tu saya bagi tahu, you need to make sure you punya glassware kena clean up betul-betul. Because other group tak dapat pun the exact, the accurate amount yang kita perlukan. The reaction should be quantitative, so meaning that you can calculate the volume of solution. The end point must be equal to the equivalence point. So there is a difference between endpoint and the equivalence point. Okay, how? So the equivalence point, kita boleh perform calculation. We can get the amounts of the solution needed for the reaction from the calculation based on stoichiometric equation that you need to write down before the experiment being started. So from there you boleh calculate dengan jelas dan dapat tahu berapa banyak penggunaan of solution yang nak guna pakai. So this is the equipment need to be used in titration. So the first one, you need to have pipette, conical flask, burette, wash bottle, funnel, and the volumetric flask. Okay, all these 6 equipment is very important. So you need to know the function of each of the equipments. For example, for pipette, the function is for measuring accurate and precise volume of solution. So the function is to deliver the precise and accurate volume of solution. So abbreviation for this pipette is TD, to deliver. Meanwhile, for conical flask is to contain, classified as a to contain apparatus because it's used as for mixing 2 types of solution. For burette is for pouring measured volume of solution, is to deliver. Wash bottle, this contain distilled water for cleaning equipment, and you want to add a solution, a distilled water solution into your volumetric flask. Funnel, the function is for transfer of liquid without spilling. And the last one is volumetric flask to make up accurate volume for solutions of known concentration. Proceed to acid-base titration. Involve a neutralization reaction in which an acid or base is reacted with equivalent amounts of base and or acid. So titration curve, pH of the solution versus volume of titrant being added. And the titrant is usually strong standard acid or strong base that known of concentration and known of compound. So this is the titrant which is placed in burette. So the titrant is this one yang masuk dalam you punya conical flask. But at last we will measure the titrant punya amount, which is the difference before and after. You will get the volume of titrant. Equivalence point is the points of stoichiometric equivalence between the analyte and the reagent. As I said, this one you boleh buat calculation. You can get it from calculation. And the last one, endpoint, a point when reaction is completed, is judged to be completed, which is there is a physical changing, which is you boleh dapat determine from color change of your solution. So this is the basic concept of the calculation. I think all of you dah tahu, dah biasa. So what you should do is first one, you need to form the chemical equation and make sure your chemical equation must be balanced because you require the coefficient of A for acid and B for alkali. So you will use this formula, this simplified formula, MAVA over MBVB equal to A over B, which is A and B is constant, or you will get from the balanced chemical equation, the coefficient from balanced chemical equation. MAVA is for acid, MBVB is for base. Okay, I want you to try to this question. This is a self exercise to make sure you all align dengan apa yang saya ajar. So there is a two question here and there is an answer for both question. So make sure you need to use the formula given below or given before. Okay, we proceed to pH calculation. Okay, so pH calculation. What is pH is all about? Okay, for information, pH is a numeric scale used to specify the acidity or basicity of an aqueous solution. So as you can see from this scale, you can see pure water. Here, water is neutral, being neither an acid nor a base. So for solution with a pH less than 7, are known as acidic. Meanwhile, for solution with pH greater than 7, we call as a basic. For your information juga, okay, pH is established by the international agreement. So when you go to other country, so you go to US, you go to UK, you go to Switzerland and so on, or Japan and so on, so still guna pakai scale yang sama. So for example, you minum susu, the pH is acidic actually, 6. Tapi bila kita add lemon pH dia 2, so the susu will curdle. So dia akan bergumpal dengan cepat membentuk keju. Nyam-nyam. Alright, so in your stomach, acid is hydrochloric acid. So the pH is 1. In your battery, especially car battery, is pH is 0 point something. So soap that you use, masa mandi, okay, so the pH is about 12, is basic. Bleach also same, pH 13. Drain cleaner is 14. Okay, so bila rasa masam-masam, sour taste, meaning that it will classify as an acid. For yang rasa pahit-pahit, normally berada di bawah ni lah, or alkaline. So if hydrogen ion is greater than OH ion, pH is below than 7. So meaning that the solution is acidic. So hydrogen ion is referred to acid, OH ion referred to alkaline. So if let's say hydrogen ion is less than OH ion, so pH is greater than 7, this solution called as a basic solution. So this is the calculation. pH is equal to negative log H plus. pKW equal to pH plus pOH. So you can get the pOH value at the same time by using this one. pKW is 14. Normally it's 14 equal to pH plus pOH. Okay, so that's it for pH calculation. So I will continue pelajaran lain pada waktu-waktu yang lain. If you have any question, you will ask me anytime. Thank you.